Hi everyone, it's Chris, and I wanted to talk a little bit further about some of the audio debug tools that I've been working on recently. So I wanted to demonstrate my audio debug log that I have here running currently in the Lyra project, just to give us some information and give us some material to work with. So in this audio debug tool, we have all sorts of information rolling by, like the name of the sound, which component it plays on, any current attenuation, and the distance of the sound away from the listener. And all of this stuff rolls by pretty quickly. Certainly in the Lyra project, there's so much action going on. But this gives us a really good way of learning the different sounds in a new project. So let's say we were kind of dumped into Lyra. There was a lot of stuff already set up, but we were kind of getting more familiar with the project. We could use this audio debug tool to see what sounds are playing, how far they are from the how far they are away from the listener, the current component they're playing on, and any attenuation used. And you can get this information lots of different ways in the Unreal Engine. But there are a few extra little tools here that will help us out with this particular setup. One of those is, actually, I'm going to slow down the game just a little bit so everything doesn't go flying by so fast with so much stuff. And so we're going to hit slow-mo here in the console commands, which slows down the game entirely. So let's say I have this weapon and I wanted to learn a little bit more about the sounds that are being used. If I look over here, I can see shotgun fire is there pretty consistently. And so if I fire off this weapon a little bit more, and let's say I double click on that weapon shotgun, it's going to be able to bring up that particular metasound. This is going to be very helpful when just kind of getting a sense of what sounds are there, what are playing back, and how we can kind of quickly recall what we're looking for. So let's say I fire this, and I got a couple of plaster impacts that fire off here. Oops. Let's see, there we go. We got a couple things that were loaded up. And so we've got impacts here. We can see how this one is particularly set up and recall it easily for editing. Beyond just the metasounds, the things that we can see here are attenuations. So if I look at this bullet impact, let's see, did I get it? All right, shotgun. One thing is I'm eventually going to place a pause button in here so that I can grab exactly what I'm going for. Currently we are reloading. Let's see. Bullet impact here shows up. Fire. Bullet impact. There we go. All right, so not only can we bring up the metasounds, but we can also bring up the attenuations. Here in the profiler, we see the distance, we see the attenuation, and using both of those pieces of information together, we can work pretty well on all of the different values for the attenuation settings, the distance, all of that sort of stuff. So that is a quick overview of what this audio profiler can do for us. Now let's talk about how it does everything. Let's kind of take a peek into how this is set up. So if I go ahead and let me just show you. So I hit P on the keyboard, and that brings it up and down. So what I'm going to do now is go over to where that is set up. I just placed it in the character. This is in the Lyra project. There is character underscore default. It was an easy place that I found to put this P command. We can certainly set it up with an action a bit more, but for right now, we're just pressing the key, the P key. It flips back and forth and toggles this on and off. creates our audio debug widget, which I'll show you here in just a sec, and it calls a particular function called update debug display. So this is calling up WPB audio debug widget. So if I look at that, let's go back. When you press the P key, this is the actual, just kind of like the header that pops up for this, and has a bit of the logic running in the background. We said that it's calling this update debug display function here, which does a few things. One thing it's going to do is it's going to spawn our audio query tool. So this is a custom little piece of code that I added in there to pull in mainly all of the information about currently active sounds. At one point, I was pulling all of the audio components and getting the audio from that, but not everything is actually playing off of an audio component. It could be just a location or 2D sound or something like that. And so then we want to be able to gather all of the sounds, and that really can only be done through code. So here is the audio query tool. It's got a couple of simple things in here, mainly this collect audio debug info, which is getting information. This is really where the magic happens. Get all of the active sounds from the audio device. So instead of polling audio components and getting metasounds or sound waves from that, this is going to the actual audio device and getting all of the active sounds. And from those sounds, I can pull information like, are you a metasound? Are you a sound wave? What audio component are you playing on? What are the attenuation settings set? If you're sound wave, what is the name of it? Distance. I can get distance to the listener. I get the location of the sound, the location of the listener, pulled from the camera location, and it figures out the distance. So I can use that distance when understanding attenuation and referencing that for the display. So it pulls all of that information in from the audio device. It iterates through all of the different things that are found. I do a little bit over here where I am comparing all of the different elements in the array that's returned and finding the closest one. I end up doing a lowest distance array and a compared array, and I'm comparing to find which one in there is at the lowest distance at all times. And then once I find it, then I put it into a sorting array or a sorted array. Those should be sorted or will be sorted in distance from the listener, and so it should always post the closest sounds in that profile. Then I am going to create the audio debug entry. So we looked at the header, which is this one that we're in, but the actual entries are this. Not very exciting, but these are the 4 text blocks that get updated when you see back over here, back here. Right? All of these entries are individual lines that they're being updated in real time. By the way, this guy's not just a bad shot. I typed in God here earlier. It's the only way I can survive anything in Lyra while I'm messing around with everything else, or really in general, because they are kicking my butt at all times. So it returns back that active audio info. Where was I? Back over here, and it returns that information. Where? Here we go. So this information, this information is being collected back over here. Once I go through the sorted array, I start collecting all sorts of information. The sound name, the audio component it's on, the type, the attenuation, all sorts of information, and all of that is updating back over here in the entry. There's these little helper functions that get the text and assign it to the entry. And the other cool thing in here is that once they're all there, showing, I can double click on these. And they will bring up that particular information. There we go. Double click on them. Now, when I double click on a particular entry, clicked on attenuation name or clicked on sound names, it is finding the asset and then opening up. There's not anything specifically in Blueprints that will go take just a string name of something and go load it up. We had to go through and find other ways of doing that. So we find the asset path by the name. We pass in a asset name. It loads up the asset registry, goes to a particular folder, and iterates through all of the assets in that folder and compares the names and gets, this is ultimately what happens, gets the soft object from that. And then eventually it will open that asset. It will take that soft path and open the subsystem, or the asset subsystem, and then open the asset with that soft object. It can't take it from the name directly. It has to create a soft object to the path, or path to the object as a soft object to load it up. And then it just brings it up, which is very handy. You can bring up those particular sounds. Come on, there we go. Now, room for improvement. Like I said, I want to put a pause button over here. I guess I could, or put another hotkey on it, which will actually pause this. And in general, Lyra, there's a lot going on, so we often, like I said, will slow down the action just to have a little bit of a better idea of what's happening over here and be able to save and recall and work with all the sounds. So hopefully that gives you a little bit of a behind the scenes as to what is happening with the audio debug tool up here. We are finding all of, let's go back here. We are finding all of the information and updating the debug display. And I do that over here every 0.1 of a second. So I could turn this up and down to update the speed of the display, but I'm finding that that's going to be updating fast enough for our purposes, at least for now. All right, so that is an overview of how this sort of audio debug profiler, metasound, attenuation setting loader works. If you have any questions on how all this ties together between the blueprint and the code, and maybe have some suggestions on how it can improve, let me know. Comment down below. Please like and subscribe if you want to have any more information like this, as I kind of dabble and display more and more information about what I'm working on. All right, thanks a lot.